Hi, 2 weeks ago we concluded our main treatment covering Java threads. I did actually point out that Java offers a mechanism for gaining synchronization. In other words, it provides a mechanism essentially that will result in the guarantee of mutual exclusion. And the work we did ago several weeks uh, since then, uh, using semaphores and to get a lock on a non-shareable resource, and we looked at the use of weight and signal to actually control mutual exclusion as far as a particular non-shareable resource was concerned. Well, I'm just going to tell you sort of fairly briefly and fairly generally about how the key word synchronization, spelt with a Z by the way in Java, operates. So let's just sort of think about this. So many programs execute serially. For example, the balance on a bank account is accessed. It may be increased by the value of a particular deposit from a client, and then the new value is copied back into the account record. And in Java, let me just have a look at this. In Java, sorry about this. The code might look like this. A is assigned the value of get balance, and the get balance is in an object A representing a client's particular bank account, and then A is increased by adding to a deposit, and then we use a method such as set balance on the object A to actually to correctly reflect the change in the balance. Okay, so it's assumed that A is an object representing a bank account. And in real life, there are many tellers and many hundreds of bank accounts. More than one thing can happen at a time. So there may be thread 1 and thread 2, and this isn't actually typographically very clear. Maybe A gets the balance on an account held in object A, and A0 gets the balance held in uh, uh, a bank balance B, and a deposit is added to both A and A0, and the balance in A is set with a new value, and the balance in B is set with the new balance A0. And that's multi-threaded. I mean, these two threads can actually operate without interfering with one another at all. But a serious problem might arise if if we let's just see what the problem is. So we've got a multi-threaded program 2, and here we've actually got 2 threads. The first is actually getting the balance from object A, and the second is actually retrieving the balance from object A at the same time. And they both add perhaps a different deposit to the value of A and A0. And what happens is that concurrently, thread 1 will actually set A's balance to A, and the second thread will set the balance in A to A0. So it's absolutely unclear exactly what the resulting value is going to be. Well, why? In real life, if a teller adds a deposit to account, a note of this fact will be recorded, so that if another tells to try to add another deposit to that account, this will actually be put on hold temporarily. Why? Well, the alternative is that the balance will only register the last deposit made, not both. Won't necessarily accumulate the value of adding two deposits serially. So multi-threadedness, as we've seen in the course, can be used to solve many different kinds of problems. For example, one thread can update a display with the current data, and another thread actually responds to the user's input. So to synchronize access, in other words, to allow or to force access to be orderly and safe, Java can put a lock on an object. And when an object is locked, the lock excludes the use of the object in particular ways by another thread. In other words, you're getting something like mutual exclusion. So to make a class and hence an object safely usable in a multi-threaded environment, some methods can be marked with this word. It's synchronized, spelt with a Z. And if a thread invokes such a method, the object is locked. And another invoking a synchronized method on the same object will block until the lock is released. So in other words, the general idea is that thread 1 can acquire a lock, and we'll see how that's done in a moment. We then execute a synchronized method using a resource that would otherwise be unsafe to share. When we finish, we can actually release the lock. And thread 2 simply will have to wait until it can obtain the lock, and it acquires the lock, then it executes a synchronized method, and then finally releases the lock. So synchronization forces two threads to operate in mutual exclusion. That's the heart of the matter. That's the thing that we need to understand. Unsynchronized access doesn't wait for a lock to be acquired and proceeds regardless. So locks are per thread. So they're given to a particular thread. So once a thread has a lock, it doesn't need to acquire it again if it invokes another synchronized method. Otherwise, it might have to wait for a lock it already possesses. So let's have a look at the class account. So it's got a variable called balance, which represents a double, and it's private. It's only visible within this class. And there's a constructor which is actually going to initialize, represent the initial deposit, and there's a synchronized method called getBalance, which returns a double, and it just simply returns the balance. And we've got a second synchronized method which involves a deposit. So you can deposit a particular amount simply by taking the balance and adding to the balance the amount. So if the value of a field can change, its value should not be read when it's being changed. So field access must be synchronized. And with synchronized declaration, two or more threads are guaranteed not to interfere with one another. In other words, access is serialized. So what's going on here is that I'm thinking of a thread accessing a particular synchronized method within a class or an object, and maybe a second thread wishes to use the synchronized method as well, in which case if the first thread has got use of the synchronized method, the second thread will have to wait. So static methods can also be synchronized. So static methods, I mean, I haven't said very much about static methods, but static methods relate to the class, and their effects are going to be felt by all objects that are instances of that class. So, maybe with a static method, you're altering the name of a design of an Xbox or something, and um, this lot can't affect any of its objects, but it might prevent another thread trying to change the name of the designer of an Xbox if we're dealing with an Xbox class. So when a subclass overrides a synchronized method, a new method may or may not be synchronized. So synchronized statements are slightly different from a synchronized method, and what we do is to use this Java construction here, synchronized followed by an expression which is the name of an object, and once you've got the lock on the object that this expression names, you can exercise these statements in mutual exclusion to any other thread that is trying to attempt to execute the same set of statements. So this construct, this Java construct, has two parts. An object to lock or gain a lock of. This expression refers to an object, and one or more statements to execute when the lock has been obtained. So statements will be executed as though it were by means of a synchronized method. All right. So here's a little method called absolute, and its purpose is to take an array of integers and to form an array of their corresponding absolute values. So what I'm going to do is to get the lock on values. So this really should be values here. It's the name of an array. So there's a typographical mistake here. I should have written values here, and values is the name of an array of integers, and I'm going to get the lock on that array and process it by following just repeatedly change every value from a negative number into a positive number, and then finish. And again, another typographical mistake here. That should be lowercase v. So not too serious when pointed out. So note that the object of a synchronized block of code is actually used in the block. In other words, I've just used an object which is values, which is the name of an array, and I'm actually processing the content of that array in the synchronized block of code. So synchronization stops threads mutually interfering with one another. But if one thread's got a lock and it's just released a lock, there must be some way or other of communicating that fact to a thread that's actually waiting on the lock. So the wait method allows a thread to wait until some event takes place, and the two methods notify all and notify tell waiting threads that some event that's actually relevant to them has taken place. And okay, so the general pattern of their use is as follows. Right. Synchronized, and I'm going to there's a little method called wait for condition, and what I'm doing inside a while loop is just to wait until condition is true, and I'm going to, if the condition isn't true, I'm going to wait. And what happens is that another thread will actually wake me up, and what I'm going to do in that case is just make sure that the condition is now true, and I skip the wait and do whatever I have to do. So a get lock, otherwise interleaving, could mean that after the while statement the condition could have been made false by another thread. When wait pauses the thread, it automatically releases the lock it's obtained. So thread suspension and the release of a lock is atomic. I mean, it happens indivisibly. Otherwise, there could be some kind of race situation where a thread jumps in and messes things up. I mean, the action of obtaining a lock is indivisible, and the releasing of a lock is indivisible. Right. Otherwise, there could be a race hazard, what's called a race hazard. A notification could happen after the lock is released, but before the thread that we're dealing with is actually suspended. In other words, the notification gets lost. And when a thread is restarted after being notified, the lock is automatically reacquired, and the condition test should always be in a loop. It cannot assume that simply being awakened means that the condition is still true. Could be many threads waiting on the same object. The notify method picks one and wakes it up, and you can't predict which one's going to be woken up. So you can actually wake all by using notify all, just to alert them that something has happened and they should check to see whether their conditions are right for them to proceed. So I'm not going to have consider communications between two threads occurring, but what I'm interested in very much is the following chunk of code. And what's happening here is that class Q represents a queue data structure, and I want to be able to do one of two things in mutual exclusion to anything on the queue. If needs be, I want to append an object onto this object that's acting as a queue. I mean, you can think of it as a linked list, which we're going to consider very shortly in the course. And in which case I want to make sure it's synchronized so that no two threads can execute the same method at the same time. And you might say, well, why might that be a problem? Well, if I add something onto an empty list, I don't want there to be any kind of interference with another thread by its trying to add something to the queue at the same time. And once I've finished appending an element onto the queue, I can notify all other possibly waiting threads of the event that something has happened. They'll be woken up. They can check to make sure that it's safe for them to proceed, and so on. The second method I'm looking at is to get a method. I mean, it would be a disaster if you allowed two different threads to remove an item from a queue, because you in effect would be giving the same element two opportunities for getting some kind of priority in some kind of action. I mean, maybe it's just information that's being obtained. There's going to be duplicate information, which could be constitute a very serious hazard. So let me just have a look at that. I'm going to work with an element object, and it's just got two fields, and there's a variable called next, and that's going to be of type element. So already we've got a bit of a recursive definition of an object. An object can itself refer to the next object in the queue. It might not, because next might be null. It means that there isn't a second object. And I've got some data, so I've got a variable called my data here of some data type or other. And I can represent the empty queue by indicating that the next element is a null object. There's nothing there. It's empty. It's an empty queue. And the header is simply this object, and at the moment there's no data. So it's actually a non-empty queue. Paradoxically, it's a queue containing two elements. There's this element that's just representing the head of the queue, and it would normally point to the next element, but the next element is null. So the end of the queue is null, and the first element in the queue is a null object. So here I've got I've succeeded in adding something to the queue. I've got an object here, element 1, so that's the first element in the queue. The head is going to, as it were, in the next field, name this element, and I called it, just for ease of reference, element 1, and it has a next field, and next field is actually going to stand for another element. And element 2, well, okay, I haven't shown any data written here, but it'll have some data written inside this data structure, and this too will also contain some data. But the next pointer is going to point to the null, the null cell. In other words, it's just empty. It doesn't really exist, if you like to put it that way. So head represents the first element on the list, and I can actually use another element, which I'm going to call tail, to represent the last element on the queue. So it's a queue with two elements, and there's a way of knowing which the first element is, and there's a way using the element called tail to point or represent the second element, which is the last element in the list. So class methods can be synchronized, although what I'm talking about, what I'm really interested in at the moment, is just normal methods that are public and would, other things being equal, allow other threads to execute those methods. And unless you mark them as being synchronized, then two different threads could actually concurrently and dangerously execute those methods. But the same thing holds with static methods. Two threads cannot execute synchronized static methods concurrently, but we don't need, at this point in time, we don't need to examine static threads or what they're doing and so on. We don't need them. We're just thinking about common or garden methods belonging to a particular object. So thread methods that you can use within synchronized code is like wait, two different forms, wait in uh, uh, seconds, I think, one waiting in for a timeout period. It's probably going to be, I think, microseconds or milliseconds, plus a further component in terms of nanoseconds. And wait methods which are capable of throwing an exception or wait, notify all. So what I could do is to have a method called transfer from from an account, and this is the amount money I want to transfer, and I want to transfer it to a particular in account, an alternative account, for a particular amount of money. So you've got an in account and a to account and a particular amount of money. And if it's a synchronized method, I want to transfer money. Maybe there's not enough money in the account. I can't transfer the amount from the from account to the to account. So what I need to do is to wait, just wait. And in waiting, I'm going to lose my log, and on the other hand, another thread might notify me that it's completed a transfer into the account from which I want to remove money. In which case, I'm going to be woken up, and maybe I'm going to check to see if this time there is enough money. And if there is, well, I'm not going to do a wait. I'm just going to, I've done the transfer. I'm going to do the transfer here, and then I can actually notify other threads waiting for me to release the lock, and they'll be woken up. Also, on wake up since the lock is returned, it's not safe to assume that some other thread hasn't come along and quickly removed funds, effectively making the account hold insufficient funds for the transfer. So if the current thread re-examines the from account and finds that there is not enough, it will be queued and suspended once again. It'll be made to wait, thereby letting another thread in, hopefully to put more money into that account. Okay, so just read through this and have a little think about this. I mean, I haven't been terribly precise in the way in which I've described as a thread gaining a lock when it executes some synchronized code, or after it's executed some synchronized code, it automatically releases the lock on that code. But the key idea I want you to understand in the context of the last few minutes discussion is that Java does have a way of ensuring mutual exclusion in the use of code that shouldn't be executed by more than one thread. So I hope you understand that. And there's a couple of programs I think I've already asked you to think about, especially I don't know. Well, have a look at these, because it provides you with a fair amount of thought-provoking content. So thanks very much for listening, and I hope you feel that this fairly short video clip has been useful. Thank you.